Okay, I want to try to run through this briefly. I discovered this last night or over the past couple of days. There are, in fact, three ways to triple a square central ghost number. Um, you already know that there's three ways to triple a cube, but for the magic ghost number square, and this is an addition form, and I'll show the one in multiplication too. This is a multiplication square at addition magic ghost number square. There's I was trying to fractalize it, separate it into four different squares, and this is the way I did it. I fractalized the magic ghost number square, and what I found out is that with each of these squares, they have a sort of machinery inside of them, I guess. I'm not really sure what to call it. But in addition form, 2 plus 2 plus 5 plus 3 plus 3 is 15 up here. Right there, there's 15. Down here, 1 plus 1 plus 5 plus 4 plus 4 is 15. That going across is 30. And with this right here, with this fractalization at this diagonal, 1 plus 1 plus 3 plus 2 plus 2 is 9. Down here, 3 plus 3 plus 7 plus 4 plus 4 is 21, which on both sides equal 30. And also the other way, 6 plus 10 plus 4 plus 10 is 30. Just like this, 4 plus 10 plus 6 plus 10 is 30. 30, whatever. Down here, 4 plus 10 plus 6 plus 10. The unused parts of this fractal cube is 30. And 4 plus 10 plus 6 plus 10 is 30. So the parts that are used to make the inner ghost numbers, 15 for instance, this and this makes 30, but on the outside, for the exterior, 6 plus 10 plus 10 plus 4. So, okay, now that's one way. Another way is simply to use the primary numbers. 6 plus 2 plus 3 plus 4 is 6, 7, 8, 9, 10, 11, 15, which would be right here. And down here, 4 plus 1 plus 4 plus 6 would be 15, which would be right here. And that going across is 30. Same as this with this way. 6 plus 2 plus 1 plus 4 would be 13, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right here. And 3 plus 4 plus 4 plus 6 would be 17, 10, 7, 17, 17, 13, and 17 is 30 on both sides. So that's three ways to do a square. Well, that's two ways, I'm sorry. The third way, and this is one that I've had for a long time that I didn't know where it fit in at, you suppress. In addition form, you use zeros on one plane to suppress that dimension. And if you work through this cube, which is actually a flat square with suppressed dimensions, you get 30. That's the third way, suppressing the third dimension. This is an addition, but I want to make sure that it works in multiplication too. So this is a magic ghost number square multiplication. I do the same thing here. And I sort of screwed up there, but 2 times 2 times 6 times 3 times 3 is 216. You can do that for yourself. Try it. 1 times 1 times 4 times 4 times 4 is 64. And if you do that multiplication, you'll find out that 64 and 216 is 13,824 on both both sides. Same as with this. 2 times 2 times 2 times 1 times 1 is 8. Down here, 3 times 3 times 12 times 4 times 4 is 1,728. You do the multiplication, and it's 13,824 on both sides. Then you use the leftover numbers. 8 times 4 times 8 times 24 times 3 times 24 is itself 13,824. Same as with this. 24, 8, 24, 3, 3, 24, 8, 24, 8, 24. I didn't circle that. 3 and 24 is by itself. That's a fractalize square. Right here, another way of doing it is 8 times 2 times 3 times 3 is 144 up here. 1 times 3 times 4 times 8 is 96. 96 times 144 is 1,000 or 13,824. Same as down here. That's just doing the simple primary numbers, the inner and the outer primary numbers. 3 times 3 times 4 times 8 is 288. 1 times 3 times 2 times 8 is 48. You multiply 48 and had that 48 and 288 is 13,824 on both sides. And 24 is in the middle. The third way of doing it again in multiplication is with multiplication, the identity for multiplication is 1. If you try to 0, it would bring the whole cube down to 0. But 1 suppresses the third dimension of the cube, which makes it a flat square in reality. And again, you'll find that when you run through this cube, if you know how to work a magic Gaussian number cube, you'll find out it comes out 13,824. So there's 3 in multiplication, the primary numbers to the corners. Well, that's this. In multiplication, same as in addition, there's 3 ways to obtain a triple for the central Gaussian number to the outer Gaussian numbers, which is this in all instances, and this in all instances. So this is just something I stumbled upon, but I like to see where it leads. Thanks a lot.